All right, guys, so in this video, we're going to go over the last of the properties that we're going to do here for the laws of exponents, okay? We're going to do the quotient raised to a positive power, and then we're going to do the quotient raised to a negative power, okay? Just like the previous videos, I've left the simplifying exponential expressions rules here. You know, you should know those by now, but if you need to take a pause here and read through those again, by all means do so, okay? So the positive power of a quotient property. So if you've got a quotient, you know, a fraction here, a fraction is a quotient, to a power, notice that both the numerator and the denominator have to be raised to that power, okay? So the numerator 4 has to be raised to the third power. The denominator 7 also has to be raised to that power, okay? It doesn't matter if we've got a numerical quotient or a variable quotient here. Both numerator and denominator have to be raised to that power, in this case the fifth, okay? I didn't evaluate this, but you could use a calculator to say, you know, what 4 cubed over 7 cubed is, okay? But let's move on to the examples here. If you want to, you can go ahead and pause the video and give these a try, and then come back and check your work, all right? So anyway, our numerator here is -3, so we're going to raise that to the fourth power. Notice again, anytime you've got a negative number to any power, but especially to an even power, you want to make sure you use parentheses so we get the sign right, okay? The denominator 5/4 to the fourth power, okay? Let's evaluate both of those. -3 to an even power is going to be positive. 3 to the fourth power is 81. And then 5 to the fourth power is going to be 625. Okay, that can't be simplified, so we'll leave that like it is. Okay, so that's the answer. All right, and number 2, we've got multiple variables here. We've got a quotient raised to a power, so our rule's still going to work. All right, so in the numerator, we've got a to the 6th, and then remember, in the previous video, we learned we got to multiply 2 times 6 here. So we're going to multiply those two exponents. In the denominator, I've got c cubed. I want to raise that to the 6th power, so I'm going to multiply those exponents as well. When I simplify the numerator, I get a to the 6th, b to the 12th. And then when I simplify the denominator, I get c to the 18th. So that's going to be my answer. Notice all these variables are different, so there's nothing I can do to simplify any further. Okay. Number 3, more stuff to deal with. I want to raise everything to the third power here. That includes the 2, okay, and it includes the 3. Sometimes students will forget that. All right, so my numerator is going to be 2 to the third power, x to the third power, and then y cubed to the third power. So notice there that I'm multiplying those two exponents for the y. In the denominator, the 3 has to be raised to the third power, and then z to the 4th is raised to the third power, so I'm multiplying those, okay? So we're going to evaluate these numeric values to the third power, and we're going to multiply these exponents to clean that up. So my numerator is going to be 8x cubed, and then y to the 9th. My denominator, 3 cubed, is 27, so 27z to the 12th, okay? Can't be simplified, so that's my answer, all right? So let's flip over to the back page and finish this up. All right, so here we've got a negative power of a quotient, and the property's a little different. So remember when we had a negative exponent with just a singular base, we would move it to the other part of the fraction to make that exponent positive, okay? So if we've got a quotient raised to a negative power, we're going to take the reciprocal of that quotient and raise it to the opposite power or the positive power. So notice 4/7 to the -3rd is equivalent to the reciprocal, so we're going to flip that fraction 4/7, make it 7/4, and that changes the exponent from a negative to a positive, okay? And then we go back to the rule we just learned, and we're going to raise both numerator and denominator to that positive power, okay? So again, notice here, we've got a negative exponent, all right? So we're going to flip that. We're going to take that reciprocal. X over y becomes y over x, and the exponent changes signs, okay? And then we use the positive power of a quotient property to simplify, okay? So again, we've got 3 examples here. So 2/3 to the -3. I'm going to flip that fraction and make it 3/2. That changes the sign of the exponent, so we've got 3/2 to the third power. Both numerator and denominator are going to be raised to that third power, so I've got 3 cubed over 2 cubed. 3 cubed is 27. 2 cubed is 8, so that's going to be my answer, 27/8. Okay? All right. Number 5 here. We're going to take the reciprocal of this. It's a little bit more complex than that 2/3, but again, we're just going to flip this fraction, and the exponent -2 will become +2. So y cubed is now in the numerator, 5x squared is now in the denominator. The exponent changed signs, okay? So the numerator, I've got y to the 3 times 2. Remember, I have to multiply those exponents. In the denominator, I've got 5 squared and then x squared raised to the 2nd power. So I'm going to multiply those exponents. Now I'm going to clean it up here. In the numerator, I get y to the 6th. In the denominator, I get 25x to the 4th, and that's the answer. All right, last one. We're going to flip this fraction. We get 5z cubed over xy to the 4th. All that raised to the +4th power, not the -4th power. All right, and let's use our rules. So we've got 5 to the 4th, and then z cubed to the 4th. Denominator, I've got x to the 4th, and then y to the 4th, raised to the 4th power. So let's clean everything up there. Numerator is going to be 625. Again, 5 to the 4th is 625. We saw that earlier in the video. Multiply the exponents, that gives us z to the 12th. Denominator, x to the 4th isn't going to change. And then I'm going to multiply the exponents for the y and get y to the 16th. Again, that can't be simplified, so that's my answer, okay? So that's how we deal with a quotient raised to either a positive power or a negative power.